I was going to introduce the webinar program first, and then Mandy's going to go through the value of Egeria. So I just wanted to draw everybody's attention to this rich webinar schedule that we've got. Now we've re-established the webinar schedule. We did about 10 in the past, which we have all the videos and presentations for. And we've got about almost a year's worth of webinars coming up in this series. So this one's all about the value of Egeria. Next month, we're going to go through lineage, what open lineage means, both the project and comparing it to our version of open lineage, which is a fascinating way of seeing the lineage across multiple repositories in your organization. And then we're going to go through the Egeria Kubernetes operator. And next year, we've got a series of webinars around building a catalog. So they come in 3 parts, which we're going to do in January, May, and June. And then in February, we've got time traveling with Egeria to be able to issue queries for the state of your metadata at some time in the past. So this is really exciting functionality that we don't think any other places do at the moment, that any other sort of metadata capability does in the way that Egeria does, because Egeria gives you that view across all the different repositories with the open metadata standard, and also being able to do that in the past. We've got a more hands-on one around building a repository connector, and then one on the integration connector. So that was just a brief whistle-stop tour to whet your appetite for the webinars to come. So I'm looking forward to this webinar because I've heard this material before and I thought it's fabulous. So I'll hand over to you, Mandy.
Thank you very much. Okay, so this particular presentation started its life as a discussion with an organization that had 3 catalogs. They have 3 catalogs, and one catalog has their API definitions in it. One catalog has all of their events, their message structures and topics, where those message structures are flowing. And the third one was a data catalog with details of the data sets, both the data sets that are part of applications and those that have been copied and distributed for different types of use cases, like sort of analytics, artificial intelligence type use cases, or other types of visualization that you can do with data. So what they wanted was, in the support of their developers and their customers, to be able to have a single view of those 3 catalogs. And so what I'm going to do today is, taking that scenario, talk about what it takes to bring together 3 catalogs into a single view. And we'll look at the choices in terms of how you do that integration, and also the types of metadata that would be involved, and how it looks when you start to bring that together. And then a sort of follow-on thing is that for this particular organization, there were a lot of their data actually came from third parties, and they had sort of terms and conditions or sharing agreements around that data. And often there was more data than was actually made available to the developers. And so they only paid for what was being used. But they wanted to be able to allow a developer to see what else is available, and to be able to request that data, so that that the developers are then able to pick up the data that they need effectively, and also see that broad landscape. And you can say, well, surely the API catalog is good enough for a developer, but actually, when you think about what they're doing, yes, they build APIs, and being able to see the API catalog is important, but their applications also need to access data. So they need the data sources, and they may also be getting receiving and sending events through the topics. So you can see very quickly that the developer does need to be able to access all of these different catalogues, and to have to issue separate queries for these is difficult. The other issue is, of course, that there are relationships between these elements, and the individual catalogues are not able to support that. So we'll talk a little bit about how that's done as well. Okay, so let's get going. So the first thing to think about is, if you think about a traditional metadata catalogue, it's written pretty much like an application, in that there's a user interface that is for the users of the catalogue, and there may be different types of roles for that audience, but effectively there's a set of metadata that the metadata catalogue supports for those users, and that's reflected in the metadata repository. So that's and so the structure of what can be stored in a metadata repository is generally driven by the use cases from the audience. Now, some metadata catalogues support extensions for additional types of metadata, and so this would allow more metadata to be put in. But the sort of rich function, the processing that the metadata catalogue does, is typically focused, well, it has to be focused around the core metadata types that particular metadata repository stores. Now, the other thing about a traditional metadata catalogue is that for the audience to see the content, it has to be stored in its metadata repository. So it's the only sort of access to data that the end users have. So when we're integrating a typical metadata catalog, we actually need to push metadata into the repository to make it visible to the audience. So given that in mind, what do we actually need to think of as we look at each of our 3 catalogs to decide how we're going to, what we can do with the existing 3 catalogs? So what do we have to think about? We need to think about the audience. So, who are the people using the event catalog, the API catalog, or the data catalog today? What do they need? Do they have everything they want? And if it isn't everything that they want, what actually could be, how could the repository be expanded to introduce those new types? And also, if we're going to bring Egeria in, Egeria has a lot of capabilities for onboarding metadata, but it's, that's not its primary purpose. And it might be that there are fantastic processing capabilities within a particular metadata repository. And what we want to do in this integration is ensure we get them, we still make use of that processing and get the maximum value out of the metadata repository, even though we're adding new metadata capability through the use of Egeria. Now, given we have to get the metadata in and out, it's very, we're limited by the API of the metadata catalog. So some metadata catalogs have a complete API that allows you to create, update, delete metadata and do all sorts of queries on it through its API. And that's the ideal situation. The other thing we like to see is that every time one of the audience of that metadata repository makes a change to it, we also want to know through an event that there's new metadata available. And with those 2 capabilities, we're able to both add metadata and update the metadata within the repository, as well as let other repositories know that new metadata has come in to that repository. Okay, I'll pause in case anyone wants to interrupt me, but please also feel free, if you've got questions, just call out. Okay, so given that we now know we've got our 3 catalogs and we now know for each one what they're capable of storing, what they're capable of processing, visualizing, plus also what their integration capabilities are in terms of their API and the events. We also need to think about that catalog's ability, its availability. So, for example, if we're going to be issuing requests for metadata from another catalog, or another catalog, or part of Egeria's integration technology, is that going to adversely affect the metadata catalog? So, is it running at 100% capacity, or is it capable of taking on more workload? And is it generally available, or available when other users going in through the Egeria integration mechanism need it? So we have to take that's the sort of non-functional aspects of the integration question. And given that information, when we bring it together, we have two choices in terms of how we integrate a particular type of catalog. So the first one is the simplest and creates the lightest load on the metadata catalog that we're integrating. And that is through what we call the integration daemon. So the integration daemon is like a client to the metadata catalog, and it is pushing metadata into it that it receives from the rest of open metadata. We'll talk about how that works in a minute. And also listening for events and then broadcasting. And what it's doing is actually making a copy of the catalog's metadata in an Egeria repository. So it's maintaining a copy, and then Egeria provides support for that metadata to the rest of the ecosystem. So it's almost like it's got a little sidecar, a little friend that is that is maintaining the copy and also pushing metadata into the metadata catalog, so its audience can see the extra value. But any queries on that metadata goes to the Egeria metadata repository. So there's no extra load on the original metadata catalog beyond the work of the integration daemon that's doing the maintenance. So, as I say, this is the simplest. The downside is, of course, we're creating a copy of that catalog. So if it's a very large catalog and it has a very high rate of change, then there's a lot of work going on in the integration daemon. But most catalogs are read more than they're written. So the percentage of updates is far lower than reads. And so typically this type of pattern is reasonable for most metadata catalogs. Okay, so that's the integration daemon. The other mechanism is this cohort mechanism that you can see hanging off this, hanging on the left-hand side here. And so it is possible for the metadata catalog to actually become a member of the peer-to-peer sharing environment, which we call a cohort. Now, when it connects in at this level, it is basically, it's using a thing called a repository proxy that is translating query requests from other catalogs into calls to the metadata catalog. So when any other connected repository asks for metadata from the metadata catalog, that request is routed, translated, and issued against the catalog. So there's no copying, there's no separate copy that's made of the catalog, and as a result, the queries have to go into the catalog. The repository proxy is still listening for events and is broadcasting to them to the other members to let them know. So they have an opportunity to make their own copy if they want, but also to be aware of what is available in the metadata catalog. So this style is very useful when the content of the metadata repository is large and volatile, but it does require a much more sophisticated API, and that it can support these the query load that's coming from the other repositories. Any questions before I move on? Because what I'd like to do is to go into a bit more detail about this cohort and what's going on in that internal sharing environment. Well, actually, before I do, there's one other thing that I need to cover. Now, here we can see there are 4 catalogs, and they are all sharing metadata, and they each have their own audience, their group of users that are connecting to it. But back to that original use case where we have the application developer that needs to see the content of the three catalogs, the event catalog, the API catalog, and the data catalog. Now, it might be one of those catalogs can be extended to support all of that metadata, but it's probably unlikely because, as I say, they tend to be written for the particular type of metadata that their traditional users use. So in order to create that combined catalog, we actually need to use an Egeria metadata repository that is capable of supporting federated queries. So federated queries are a capability in Egeria. It is possible for the other catalogs to add that into their support, but we just don't know of any catalog that's done it outside of the Egeria project. So basically, in order to support a single catalog view of all these three grey catalogs I'm showing, we need to put in an Egeria metadata server and the Egeria UI, and that when the UI issues requests, or when what are called access service APIs are called, they automatically will issue a federated query. So the impact is that if it says, give me everything that's related to customer data, that request then goes, is then federated across the cohort. So all four of those metadata repositories will be queried and the results combined and returned to the UI. So that's how that single view of the catalog is provided, even though the metadata is distributed across multiple repositories. Okay, so let's dig into a bit more detail about how on earth that is possible in the Egeria environment. So what's happening is at the lowest level, Egeria is shredding the metadata down into three basic types. An entity, which you can think of as an object, it's a thing. Classifications, which are sort of labels with properties that are attached to the entity, and then relationships between entities. And so this simple model is really all we need to represent any type of metadata. Now, of course, there are different types. We talk about things called assets, which are the things that we're managing, schemas, which describe the structure of data. We might talk about governance policies, which describe how something should be managed. We think of other things. We have things like user profiles that describe a person, so we can assign ownership. So there are lots of different types of concepts and different types of metadata that are found in all of these different metadata tools. And so in this basic structure, in the header of these elements is a type definition, and that type definition is something that Egeria defines. It's got, I think, about 700 different types, which shows you that, you know, there's a big scope of metadata that's provided by tools today. And so when these elements flow across the cohort and are either being translated by the integration daemon, or they're being translated by the repository proxy, that type information is looked at and then mapped to the API of the particular metadata repository. Now, so one of the ways to think about this is that this is actually a very large virtual graph of entities linked by relationships with labels or classifications attached to the entities. Now, because that content is in all of the, you know, spread across all of the repositories, actually what flows between them are these little graph fragments. So it might be a classification with a summary of an entity, and we call that an entity proxy. It might be the whole entity, and that typically may have all the classifications that a particular repository knows about, and also a relationship with two summaries of the entity at either end. So each of these can be sent independently and stored independently in the in sort of any of those repositories that we see in the cohort. So when that federated query happens, what it's doing is actually reassembling that subgraph that the query represents, and then presenting it back to the user. So let me do a sort of simple illustration of what's going on and why this is so valuable. So here we've got two particular metadata repositories, and in one we've loaded information about a database. So this is the data catalog, you could think of that. So we know about a particular database column. We've also got another catalog in which we defined a glossary term. And so really what we want to do is to say, well, I want to link my database column to the glossary term to say this is the type of data that's stored in the database column. So how do we do that? We have a number of choices. What we can do first is we can take a copy of the glossary term and copy it through the cohort integration into the first metadata catalog, and then link it together to say this glossary term describes the meaning of the data stored in this database column. And when we do that, we only allow one writable, updatable copy, and that's in the original metadata repository. And so the copy that goes into the other repository is read-only, and we call that a reference copy. So if you can imagine, we've got three elements now. We've got two entities, the database column and the glossary term, with a relationship between them, and that is spread across the two repositories. Now, it might be that neither of those repositories support each other's metadata, in which case we can bring two reference copies, a copy of each of the database column and the glossary term, into a third repository and store the relationship there. So you can imagine that if you have three repositories that didn't have any overlap in the metadata, adding in a third, an Egeria metadata repository that can store any type of metadata, means that we can form these relationships. And then when that federated query is issued across the collection of repositories, we then retrieve the three elements as if they were all stored together. The other value of this, this ability to sort of bring together the graph fragments from the different repositories, is that we can add capabilities such as governance, classifications, and things that are not available in any of the other repositories. So you are no longer limited by the capabilities of the tools that you've already bought. You can take the value from them and augment it with an Egeria repository that supports it, or maybe a wider range of metadata than your original repositories. Okay, so given that background, let's look at this picture again. So you can now see the cohort, and you can imagine within each of these repositories are subsets of the metadata. And here I'm showing both integration styles. So on the left-hand side, we've got the metadata catalog that's actually connecting directly into the cohort and is receiving all of that traffic, all of the requests and notifications about the metadata that's available in any of the connected metadata repositories. I'm also showing on the right-hand side the connection of a metadata catalog that's connected through the integration daemon. And I said it was an easier integration to do. And the reason is that the repository services that that is used across the cohort uses those tiny graph fragments as its basic types. And so the repository proxy and the catalog that connects in through that is working with those very fine-grained elements. The integration daemon has a number of services that are specialized for different types of catalog, and it uses much more coarse-grained objects and sits on what we call the common services. So the common services provide a lot of metadata governance that enables that requires less work to process the metadata. So an example of that is the deduplication services that sit in the common services. So this means that if multiple tools have loaded information about the same database, our common services and access services will be able to link those together. And then when the integration daemon says, tell me about databases, it will only get one copy. So we will be automatically combining knowledge about the same database, even though it's coming from different places. So when you use the integration daemon, Egeria will deduplicate the metadata that has been loaded multiple times into the different repositories. Whereas when you connect in through the repository proxy, you're not involved in the common services, and so your metadata catalog has to do that work itself. And it might be that that catalog is already capable of supporting the deduplication, and so that's fine. Otherwise, it's something that needs to be considered, because otherwise the users of that catalog will start to see duplicate results whenever they issue queries on the metadata repository. So what are the other types of metadata governance that we offer? So security. So we can do very fine-grained security around zones or other types of properties in the metadata. We support something called effective time or effectivity dating. So you can say, okay, I want to add this asset, but I don't want to see it until next Friday when a new regulation is enabled. Or a new service is added or activated at that time. So it's possible to set up metadata that is going to be needed in the future through our effectivity dating. Other types of things is that Egeria will keep track of the changes that are happening to a very complex object and create summaries of that automatically, and also support something called mementos. So when we are moving metadata between elements and a particular element is deleted, we keep what we call a memento copy of that element so that the lineage flow is still visible at that time. So all of that is handled in the common services, and the access services then create those more coarse-grained objects that the integration daemon makes use of. So all in all, it's a more sophisticated and simpler integration style when we're using the integration daemon, but the downside is, of course, we have to copy the metadata from the original metadata repository into an Egeria metadata repository so that it's visible to the rest of the cohort. Okay, so that's the mechanisms. Now I'm going to spend a little bit of time talking about the different types of metadata. So I said we have entities, relationships, and classifications, and each of those in their header has a type. So I'm going to talk about those types. So the most important, on often, the type of metadata that is the focus of most metadata catalogs is something called the asset. So this is a description of a resource. So this might be a file, an API, an event that is of value to the organization and needs to be governed. And every organization makes a different choice in terms of the granularity of their assets. So are we talking about file systems? Are we talking about servers? Or are we talking about individual files and individual components within a particular application? These are all valid choices. But essentially, the assets are the things that you want to catalog, you want to probably give an owner to, you want to set up policies around how that asset should be managed. So those are the things that most catalogs are built around. And then we start to attach detailed information with it. And so one of the pieces of information that's often attached is how to access the actual resource. So if you think of the resource as a database, the connection that's attached to the description of that database, the asset, is called the connection, and it has two more detailed types to it. elements to it, I'm sorry. One is called the connector type. That describes the code, the driver, the connector that's needed to access that resource. So if it's a database, it would be a database driver. And then the endpoint is where, what's the network address of it? How do I call it? And so that combination with the connection information, which is things like user information, is the metadata needed to access the content of the resource in the IT landscape. Another type of thing that we can attach is a thing called a schema element, and this is the structure of the data. So if you think about a database, it may have multiple schemas, and in that schema are tables and columns. If we think about a CSV file, it is one table effectively with a set of columns. If we think about an API, then it often has a number of operations, and each operation has maybe a header, a request, and maybe a response. So each type of element we have, each type of asset we have, I'm sorry, often has some sort of structural information. Now we might be a document, and so the schema element is that's what we call unstructured data, so that wouldn't necessarily have a schema element attached to it or a set of elements. But most things that have some sort of structure in their data we would use schema elements to describe that structure. And so here I've got some examples of different schema structures for different types of assets. So the assets are shown in yellow and the schemas are shown in purple. And as you can see, so the API has a set of API operations. A database has multiple schemas, and within that, tables, views, and columns. An event on a topic may be structured according to what we call an event type, which it's typically is a sort of single nested structure of elements, and a CSV file is effectively a single table with a number of columns. Now, one of the things that we've done with Egeria is that we have aligned these types, because we start to think about how do we want to govern and query metadata. We might want to say, I want to know where customer name is. And customer name might be a parameter on an API. It might be a field in an event. It might be a column in a database table, or a column in a CSV file. So we want to be able to look at these data fields irrespective of the type of technology that's been involved. So the Egeria types support what we call inheritance, and that means that we can access something using a generic type, even though it's actually something much more specific. So we can say, tell me about assets, and when we issue a query about assets, we may get information about topics, APIs, CSV files, and databases. Tell me a query about a schema attribute, which is a data field that has a certain characteristic, and what might be returned are any of these specific types of attributes that are associated with particular types of assets. So with this, we can either make very, very specific queries. I want to know about API parameters that have this characteristic. So very, very specific type query, or I can say, tell me about schema attributes, any type of schema attributes that have this characteristic. So we can then get a much more generic. So it means that the caller can choose how much is filtered out depending on the type of metadata that they request. We can also govern, at a higher level, and say and make policies about assets in general, or specific policies about databases, for example. So this type inheritance is very important to be able to sort of have a very generic view of things, or to go down and be very, very specific about how a particular type of technology should be managed. Okay, so those are the sort of individual elements that we could get from each repository. Let's now talk about how we could link those together. And I've called this a data map. So what this is saying is, what additional metadata could we add to all those basic technical metadata descriptions, the assets and the schema types that have been extracted from the technology themselves in each of these independent catalogs? And how can we sort of link them together to show how they correspond? So the very first example here is, and I mentioned it earlier, something we call semantic assignment. So this is a relationship that says that this particular data field, for example, has this meaning, and the meaning is described in the glossary term. So what we have here is a single glossary term, and it is linked to each of the places where the unique customer identifier in this example appears in each of the schemas. So even though it's called customer ID, customer no, cust ID in these different places, because it's linked to the single glossary term, we know in all of these cases that the identifier that's used for customers is located in all of these places. So we're not limited to the actual spelling that a particular developer has used on a particular schema. So that's what it means, but there are other things that we can add. So search keywords are typically added by the asset owner to make things more searchable. So for example, if there are common keywords that people always want to see, we can attach these keywords to make it easier for people to find it. So that's often added by the owner of the asset. Informal tags are for the consumers to add. So you can imagine some sort of crowdsourcing of common terms that people are using. And so we can, these are called informal tags. We can add reference data values, so you can build your own set of tagging for different types of regulations. For example, you might have a set of reference data values that describe different levels of privacy tags. So that's an example of that. We can add governance classifications. So what's the retention requirement? What is the, how confident are we that this is correct? So it's quality. How confidential is this particular type of data? We can say where it's located. We can show its lineage. I'll talk a little bit more about that in a minute. So there are many, many ways that we can augment this metadata to make it easy to find, to define very clearly how it should be managed. And then because this is all machine readable, then automate the management so that humans are not required to do sort of boring, repetitive tasks around making sure that things are being managed properly. So I mentioned lineage, and so there are multiple ways of connecting elements together to show their relationship. So here I've got a very simple model of an API, and the API calls a component, software component. So basically, whenever that API is called from the outside, it involves calling a Java component or whatever. That Java component pushes events out to a specific topic. And may also store data into a database. So these process calls relationships show that that call response relationship between different types of assets. We can also show data flows. So if you've got a sort of data flow type processing going on, control flows where you've got more workflow type control flow between different components. And then something called lineage mapping, which is showing how independent assets that have been deployed independently how assets in one system are related to assets in another. So this allows us to create that that connection between somewhat independent components. And so from that, we can start to sort of say, well, where is this coming from? What is this dependent on? If I delete this, what's going to break type questions. And so this picture is really showing more of this metadata that I've been talking about being built out. So in the center is a data or process asset, the yellow box. And then we can show in orange to the left-hand side is actually the infrastructure that's supporting it. And that's very useful to know in case that infrastructure goes down, what are the assets that are impacted. We can then link up from those assets to the part of the business that's making use of them. So we can see very quickly which part of the business is impacted. We can link to its glossary terms, and this is the semantic assignment I talked about earlier. We can link to the governance rules that control how this particular asset can be used and how it should be managed, for example. We can connect to the people that are responsible for it, the owner, the steward, for example. And maybe, and we can also link feedback from people who are using that thing. So this could be comments, it could be tags, the informal tags that I talked about, it could be review comments. So you can start to build up a communication between the owners of assets and the people who are using them. We can do what we call metadata discovery, so we can run automated analytics on the resources that the asset represents and discover relationships between columns in the database, assess the quality of the content, make other types of assessments in terms of what we think the data might mean through these discovery analysis reports. And they are represented, all of the findings are represented and connected to the asset that was for the resource that was analysed. Now, the final part is I talked about the fact that in this particular scenario, there was the data asset that was made available to the application developer might be a subset of what was completely available. And so here you see the lineage mapping that links it to the source of the data asset. And in there, that could be the description of the resource from the third party that provided the data set. And that could have a schema that actually shows all of the different fields that are available in the full data set. So the developer can search that and then understand, oh, actually, if I had these extra fields, I could support the application that I'm trying to write. And then it's a question of whether there could be an automatic approval or whether the governance sort of ownership tags and things like that can be used to route the request for more data to an individual that is then responsible for giving the authorization to acquire and provision those extra data fields into the main asset that people are working with. So lots of different use cases are possible as we build out a richer picture of metadata. And here I think this is just really describing exactly what I said in a little bit more detail, just sort of highlighting that extra information that's been added to allow the processing, understanding the license and other types of rules around how that approval could be managed. So in this session, I hope you've seen so far, we've talked about the different mechanisms for connecting together a set of catalogs that each cover different types of metadata and the impact on those choices. We also talked about the ability, the fact that the cohort itself works with graph fragments effectively, and then when we're doing a federated query is connecting these fragments together to create an answer for a particular consumer. And then we've looked at all the different, with that extra capability and with including an Egeria metadata server in the cohort, we can then start expanding the use cases and the different types of capability that we can make use of this metadata by sort of covering the infrastructure, the governance, the doing metadata discovery on top of this. There's lots of things that we can do to actually build out that huge capability. So now you might say, yeah, that sounds great. I'd like to do this. What does Egeria look like? I talked about it in its sort of architectural and capability type view. What I want to do now, just to finish off the session, is to talk a little bit about the technology that's sitting behind, that's supporting these use cases that I've been talking about. So the main Egeria capability that supports the different types of servers, the repository proxy, the integration daemon, the metadata server, is supported within a process called the OMAG server platform. And this can support running multiple different types of servers. So you could have your metadata server, your repository proxy, and your integration daemon all running in the same platform, or they could be in different platforms, or you could have multiple repositories or of any type, or any type of server within the platform. And so this is what we call multi-tenant. That whenever you make a REST call to the platform, inside the URL is the name of the server that you're talking to, and the platform will route the request to the right server and validate the security and all sorts of other things. So that's the sort of multi-tenant. Now there are environments where actually the hardware is very small and there's a very limited amount of function that's required, and so you could run the platform on something like a Raspberry Pi, and it may only have one server in it, which is all that's needed for that particular environment. And we can connect those two platforms together. You know, the servers involved running on, you know, in the two starts could be part of the same cohort. It doesn't matter how we've partitioned the servers onto the platforms. It's completely independent, and you can move a server from one platform to another with very little impact. At the other end of the spectrum is a situation where we may be running a server a set of metadata servers that are extremely important and have to be available all the time. In which case it's possible to run a copy of the same server on lots of different platforms, and with, as long as you put a sort of a network router for the request to it to spread the workload across, these servers will work successfully in this sort of highly horizontally scaled out style. And that's what's represented by the Kubernetes picture there. So we're able to go very small to the edge, medium size, or how a developer often runs it, which is lots of different types of servers on the same single platform, plus also this highly horizontally scalable operation. And it's exactly the same platform, it's exactly the same support code, just configured differently to run in different ways. And if we think about those servers, and I talked a little bit about how they fit together, this hierarchy picture here talks about the different types of servers. So I've talked about some of them, which is the metadata server, the repository proxy, and the integration daemon, but there are other types of servers to support even more types of use cases that we'll be covering in later sessions in the webinar series. But if you see the arrows pointing up, you can say, replace that arrow with ISA. So an integration daemon is a governance server. And there were three other types: the engine host, the data engine proxy, and the open lineage server. The governance server itself is an OMAG server. So where you saw OMAG server on the platform, we can run a governance server. The view servers used to support our user interface. And then the cohort members are the servers that are able to connect to the cohort and do that direct sharing, peer-to-peer sharing as part of the cohort. So that's the repository proxy that I talked about, the metadata server, and the metadata access point is the same server with all the APIs, but it doesn't have a repository. And then our conformance test suite, which is monitoring the conformance of a particular server. So typically that's only used in a test environment because it throws an awful lot of good and bad metadata at the server it's testing in order to ensure that it replies in a compliant way. And then the main picture here, you can see those server types connected together. So you see the cohort in the center, and that's like the center of the onion. and then calling the metadata access point or the metadata server are the governance servers, the integration daemon, the engine host, the data engine proxy, and the open lineage server, and the view server for the UI. And then you see external technologies connecting into either through the governance server, which is the example I showed with the integration daemon, and the repository proxy on the right-hand side, connecting directly into the cohort. So that is the that is the capability that we have with Egeria. In terms of its value, what we're attempting to do is to get the maximum value out of your existing metadata repositories and all the capabilities they provide, and then augment that with a set of libraries that make integration between those repositories as simple as possible, and also the ability to extend and add new types of metadata to enable you to automate and govern those environments as if you have a single repository. And this is becoming increasingly important because many organizations use multiple cloud environments. Each of those environments has an embedded metadata capability. And so if we can connect those together, then we can start to link what is on each of these cloud platforms with the on-premises data centers as well. And the enterprise that is spread across these very heterogeneous environments is able to start to have a coherent view of what they have, where it is, and how it's being managed. So thank you very much. There's a little bit of time for questions, if anybody has any.
Yes, I have a question.
Yes.
Mandy, I know that we can describe database structure with schemas, but do we have something special for star schema used in all app applications?
Yes.
It's built in, right?
Yes. So yes, we can do star schemas with the structures that we have.
Okay, nice. Thank you.
Mm-hmm. Now, if you find that there's something specific about the star schema that we've made a mistake with and we need to extend it, just ask and we can extend the types. And that's one of the good thing about our types, is that they are easy to extend, which is each release you'll see that there are more types coming in. So if you have any problems, please let the community know and we will address them.
Okay, thank you.
Mm-hmm. Any other questions?
Actually, I have another one.
Yes, of course.
It's just enormous size of things we saw on this presentation. But the question is it ready for use, some kind of alpha state or maybe production ready? If we have every type of server available right now to try and run on a, let's say, small or medium organization.
Yeah, so there are bits of it that have been in production for a number of years, and that is the cohort and the repository services. The access services, some of those are in production as well in some organizations. So each component has what we call a content status associated with it that says whether it's released, which means it's production ready, or it is tech preview, which means it's the coding's finished. We've done our testing, but we haven't seen, it hasn't been, it's still, we're still hoping for more feedback on it. So, and then we have something which is in development, and those components are, they're actively being worked on. So there may be function that you can use, but you need to use that with care beyond the sort of POC evaluation stage. So we are actively working on the code all the time. We basically take each component through those stages and we make everything visible all the time so that you can look at something that you might want to use in the future that's in development and provide feedback while it's being developed, basically sort of guide us so that we cover the function you need. So the important thing to do is to look at the components that you want to use and see what their status is. And if it says that it's released, it is production ready. The platform's production ready, the repository services are production ready, and some of the access services are as well. So there's a lot that is, but of course there is also a lot that we're still building.
Nice, thank you.
You're welcome. Any more questions? Okay, well, while you're thinking, I'm going to hand back to David to talk about the next webinar.
Okay, that was really good. So the next webinar is all about open lineage, and that phrase has come up in 2 places. There's a new standard which allows you to, if you create lineage in that standard, then we hoped to be able to consume that in Egeria. There's ongoing work that will be able to take those formats into Egeria. So that would allow you to connect into Spark and anything else that produces that format. Also, ING Bank are running open lineage with a user interface in production. So they're going to take us through that part as well, the open lineages services. So I hope that you can make it next month on the 8th of November. The details will be coming out in Slack, and it's present in the documentation website for Egeria, the sort of all the previous webinars and this plan for the webinars that are coming up. Thank you for coming to this webinar, and look forward to seeing you in the future.